Good morning, my dear student, and welcome to my channel, that is Easy Chemistry by SBG. We are seeing the spectroscopy, ultraviolet and visible spectroscopy. In last lecture, we have seen the basic concept of the ultraviolet and visible spectroscopy and terms related to the calculation of lambda max. Now today we will solve some examples related to the diene. So first example is given here. It is an diene. The basic value of diene is 215 nanometer here because it is not the homoannular diene. The basic value is value for the diene is 215 nanometer. In some book this value is given as 214 nanometer, but it doesn't matter. 215 or 214 nanometer is the exact value. Then exocyclic double bond is here, no any extra conjugation, but see this A and B ring. This double bond is exocyclic to the ring A, and this double bond is exocyclic to the ring B. So the exocyclic double bond, total contribution by one exocyclic double bond is by 5, so 2 exocyclic double bond, so total contribution is by 10. Then see the substituents. Substituent is 1, 2 and 3 substituents are there. So substituent, there are total 5 nanometer contribution by one substituent, so by 3 substituents 15 nanometer will be the contribution. After calculation this value becomes 214 nanometer, and it is exactly to the observed wavelength, and observed wavelength and wavelength calculated can be differ by 5 to 6 nanometer, doesn't matter. And second example, it is an homoannular diene. The basic value for the homoannular diene is 254 nanometer. These are in ring A, both the double bond in the ring A, so this is an homoannular diene. Now this double bond is in extra conjugated, so extra conjugation contributed by 30 nanometer. Then substituents, it's 1, second substituent, third, fourth, and this one is fifth substituent. So one substituent is contributed by 5. There are total 5 substituents. Substituents is equal to 5. One substituent is contributed by 5, so total contribution by substituent is 25 nanometer. So as we make the total, then it becomes 5 plus 5, 0, 1 here, 3, 0, 9 nanometer, and it is exactly equals to the observed wavelength. And this example was asked in October 2014 examination of the Savitribai Phule Pune University examination. Next example is now it is an diene again, and this example was asked in October 2013 and October 2016 in Savitribai Phule Pune University exam. Now the basic value for this is 215 nanometer. Basic value is equal to 215 nanometer. Then see the exocyclic double bond. This bond is exocyclic to the ring. So exocyclic double bond is contributed by 5 nanometer. Then extended conjugation, other than diene there is an one double bond, so extra conjugation is equal to 30 nanometer. Now see the substituents 1 and 2, there are 2 substituents, so 10 nanometer is contributed by 2 substituents. Now make the total, so 5 plus 5 is 10, 1, 2, 3, 6, then 260 nanometer will be the total, and it is exactly equals to the observed lambda value. Now see the next example, and this example was asked in the Savitribai Phule University examination in April 2014. So for this, it is again an homoannular diene. If we consider this double bond, and this double bond is a part of the one and the same ring, so the basic value for the homoannular diene, basic value is 254 nanometer. Then there is an extra conjugation, so extra conjugation is contributed by this double bond is extra other than diene, so it is contributed by 30 nanometer value. Then exocyclic double bond, if we consider the ring A, B and ring C, then this double bond is exocyclic to the ring C, and this double bond is exocyclic to the ring B. So total exocyclic double bonds are the 2. So total contribution by exocyclic double bond is 10 nanometer. Then substituents 1, 2, 3, then 4, and this one 5. Total 5 substituent. Each substituent contributes by 5 nanometer value, so becomes 25 nanometer contribution by substituents. Makes the total 4 plus 5 9, so 1, it will becomes 319 nanometer value. So the lambda calculated is 390 nanometer. The observed value and calculated value may differ by the 5 to 6 nanometer value, it doesn't matter. Next example is, now this example was asked in the April 2012 examination. April 2012 examination. Now this is again an homoannular diene. Consider ring A and B. These two double bonds are in the same ring, so the basic for the homoannular diene, is equals to 254 nanometer value. Now see the exocyclic double bond, or first extra conjugation. Now one double bond is extra, so it is contributed by the 30 nanometer value. Then exocyclic double bond, this double bond is exocyclic to the ring B, so the exocyclic contribution is by 5. Exocyclic double bond contributed by 5 nanometer value. Next is substituent. Substituents, count the substituents, 1, then, so consider this example. Now ring A, B and C, the double bond is in the one and the same ring, so it is an homoannular diene. So basic value for homoannular diene it's equal to 254 nanometer. Now extra conjugation, other than the diene there are two extra double bonds, so we have to take the contribution by extra double bond is 60 nanometer. Then again these two double bond are in the same ring, so we have to consider the homoannular double bond again. So the homoannular double bond contributed again by 39 nanometer value, because this extra conjugated double bond in the ring B, they are also in the same ring, that is why they are contributed by value 39. Then exocyclic double bond, now consider the ring A. This bond is exo to the ring A. Now this bond is exo to the ring B, and this bond is exo to the ring C. The total exocyclic double bonds are 3, and each double bond is contributed by 5 value. Total are the 3 exocyclic double bond, and the total contribution by exocyclic double bond is by 15 nanometer. Then substituent, or we call it as a ring residue. See the substituent: 1 is 2, then this 3. Now this position, this substituent is contributed towards this double bond as well as towards this double bond, so I have to take the twice this. Then this substituent is also contributed towards this and this one. So 1, 2, 3, 4 and 5 substituents are there. Total 5 substituent, and each contributed by 5. So total contribution by substituent is 25 nanometers. After making the total, we get 393 nanometer value. Lambda calculated is equal to 393 nanometer value, and it is differ only by 5 nanometer from the lambda observed, and it is allowed. This example was asked in the October 2011 in Savitribai Phule Pune University examination. Next example is this one. Now see, this is an heterocyclic diene, and the basic value for the heterocyclic diene is 215 nanometer. Basic value 215 nanometer. Then extra conjugation is contributed by 30 nanometer. There is a one extra conjugation. Then exocyclic double bond. There are two exocyclic double bond. If we consider the ring A, this bond is exo to the ring A. Then this bond is exo to the ring B. So the total exocyclic double bonds are 2, and each contributed by 5. So total contribution by exocyclic double bond is 10. Substituent of the ring residue, see, this is 1, then 2, 3 and 4. There are total 4 substituents, so each contributed by 5 nanometer, so it will be 20 nanometer contribution. So making the total, it will become 275 nanometer. And it is exactly to the lambda observed. The last example is this. So second last example, I think it's second last. It is very simple example. It is in the diene. Now the basic value for this diene is this transitoid diene. Basic value is 215 nanometer. Then no extra conjugation with